Okay, so this is the notes page on solving systems with the calculator, and we're going to do a lot of word problems. And before we get into it, I do want to just really quickly tell you what a matrix is. This is a matrix. It's just an array of numbers, and you can use it to organize information. So the columns are immature, juvenile, adult, and the rows are male and female. So this element, that's what each individual number in here is called, because of its location, means that there are 52 juvenile males. Okay, when you're talking about dimensions, you always talk about the rows first and then the columns. So it's like RC Cola or remote control car. So this matrix here is a 2 by 3 matrix. Alright, so we can write a system in a matrix called an augmented matrix, but you need to make sure your system is in standard form, ax plus by plus cz equals d, and if you're missing a variable, you need to make sure you put the placeholder 0 in. So what you would do is just take the coefficients. So for equation 1, 3, -2, 1, and then the constant 5, and then 1, 3, -1, understood -1, and then constant 0, and then -1, 0, 4, 11. This is called an augmented matrix. And then if you have a TI 36X Pro, then you may have noticed there is something called a system solver. So if you hit that second and then that tangent button, you'll get the system solver, and it'll solve two types of systems. It'll solve, a 2 by 2 linear equation, which is 2 rows, 2 columns, so an x and a y, a system of 2 variables, and it'll solve a 3 by 3 linear system, which is what we have here. Okay, so we're going to hit number 2, and then you can see the augmented matrix, and I already have numbers in here. Well, you can just type over them. So you just would hit 3, enter, and then -2, enter, and then 1, enter, and then 5, enter, and then 1, 3, -1, 0, and then -1, 0, 4, and 11, and we put that augmented matrix in for this system, and then when you hit solve, it'll give you the answers. So this system has answer x is 49 over 45, and then you see that little arrow, that means go down, and then y is 29 over 45, and then z is 136 over 45. Okay, so if we wanted to solve example A, where it says solve again, it takes you back to that augmented matrix, and this is already in standard form, so you don't have to write the matrix down. I think you can do it in your head. So the x coefficient is 1, the y coefficient is -1, then 3, and then 3. So that takes care of equation 1. Equation 2 would be 4, -8, 32, 24. Equation 3 would be 2, -3, 11, and 4, and then solve. And if it's no solution, it'll tell you that. No solution. Let's see what happens with this one. Okay, so we'll try 1, 4, -2, -3. I'm just typing in the coefficients. You can pause the video and try this one and click to see if we came up with the same thing. This one is -13 over 3, 8 over 3, 14 over 3. Okay, and if you tried the next one, you would get -1, 5, 0. If you didn't get that, maybe because there's a 0y that you can't forget. You have to put a 0 in. Okay, and so I wanted to show you one more thing before we move on. If you have a system of two unknowns, you can go to the system solver, but you would pick number 1, and so the format is different. It's telling you to put the coefficients in. It has the x, and you might need to change that plus to a minus. So so if I put in 1, and then it asks press plus or minus, it's a plus, and then another 1, and then 4, and then 3 plus 3, and then 12. Now this answer is not going to be what you would write on your paper. If it's a 2 by 2, it will just say infinitely many solutions, but remember you need to solve for x and let y be all real numbers, so be aware of that. But look at what it will do if you have infinitely many solutions when you have a 3 by 3. So let's say I'm going to make up the same equation. So we have x plus y plus z equals 1, and then 2x plus 2y plus 2z equals 2, and then 3x plus 3y plus 3z equals 3. That's the same plane. So this is infinitely many solutions, but watch what it'll do for you. It will tell you that x is 1 minus y minus z, and y is y, and z is z. Since I made up such a simple system, you have to let z be all real numbers and y be all real numbers. But the point is, it will tell you, it'll give you the infinitely many solutions, x in terms of z, y in terms of z, z is z. So students really like that. Okay, all right, let's head to word problems. All right, so the first word problem: Billy's restaurant orders 200 flowers for Mother's Day. They ordered carnations at $1.50 each, roses at $5.75 each, and daisies at $2.60 each. They ordered mostly carnations and 20 fewer roses than daisies. The total order came to $589.50. And then the question, just like before, the question is where you go to define your variables. How many of each type of flower was ordered? Now, I don't like to use X, Y, and Z because it messes with my brain. I can't remember which is which. So I like to use the alphabet. So how many of each type of flower? So the 3 types of flowers are C, carnations. So I'm going to say let's let C be number of carnations. And then there is roses. So I'll let R be number of roses. And then there are daisies. So I'm going to let D equal number of daisies. So if I have 3 unknowns, I need 3 equations. Okay, so you want to look for total amounts. All right, and so the very first thing you see is that he ordered 200 flowers for Mother's Day. So these are all flowers. So this first is a total flower equation is what I'm going to call it. Carnations plus roses plus daisies is equal to 200 total flowers. So this is my total flower equation. Alright, then it says that they paid $1.50 for carnations, $5.75 for roses, $2.60 each. So we've got a bunch of money. Do we have a total money amount? Yes, we do. There it is. So that money comes from $1.50 times carnations plus $5.75 times the number of roses plus $2.60 times the number of daisies, and that total money amount is $589.5. So I have a total money equation. And 9 times out of 10, the word problems that you get, you're going to have a total, 2 types of totals. Now the third equation, you know, you need 3 equations. The third equation is really is the most difficult. So it comes from this sentence right here. They ordered mostly carnations and 20 fewer roses than daisies. So that's not it. This is so hard for students, and it was hard for me. And then I had to teach it, and I have come up with a way to help me and everyone else. 20 fewer roses than daisies. So before we think about algebra, we just want to think about, well, who did we buy more of? 20 fewer roses than daisies. Doesn't that mean they bought more daisies than roses? Right? So you can do that through reading comprehension. That's not math, and you can do that. Be confident about that. So the question is, where's the 20 go? All right. So if you can tell me which number's bigger, then you can do this. Here's what I do: is I write daisies and roses on opposite sides of the equal sign, and then I ask myself, who needs the help? We want them to equal, but we just said they ordered more daisies through reading comprehension, right? So doesn't roses need the help to make it equal? 20 fewer roses, that means you're going to actually add 20 to the roses. Then you can check it out. If you ordered 10 roses, how many daisies did you order? 30. So you see, that checks out. So that's my method of doing it. When I hear something like that, 20 fewer roses and daisies, I'd say, okay, that means they ordered more daisies, and I put them on opposite sides, and I ask myself, who needs the help? Okay, now, this is not in standard form, so we want to solve this using the matrices. So what I need to do is reorder this, and I need to make sure I maintain the order. C, R, and D is the order I've chosen. So there is no C, so I'm going to put 0C, and then I need to move the R over to the left, so that's minus 1R, and D's already on the left, and 20 is already on the right. So that is my third equation. All right, now to solve it, I'm just going to use my calculator, and remember, it's system solver right above the tangent key, and this is a 3 by 3 matrix, 3 equations, 3 unknowns. So now I'm going to put the coefficients in. And then I'm going to solve it. And just remember the order. CRD is X, Y, Z. So that X equals 80 stands for 80 carnations. 80 carnations. And then if you go down, there's 50 roses. I've run out of room, that's why I'm not rewriting this. And then if you go down, there's 70 daisies. And you can check your work. According to this, we ordered 20 fewer roses and daisies, and sure enough, there it is. Alright, let's try another one. The Arcadium Arcade in Lynchburg, Tennessee uses 3 different colored tokens for their game machines. For $20, you can purchase the following mixtures of tokens: 14 gold, 20 silver, 24 bronze, or 20 gold, 15 silver, and 19 bronze, or 30 gold, 5 silver, 13 bronze. And this is an interesting question. What is the monetary value of each token? So this question was how many of each type. This is talking about the monetary value, and that's why I don't want you to just put carnations, roses, daisies. I want you to put number of, because sometimes I might ask you for the number of coins, or like this one, I'm asking you for the monetary value of each token. So let's let B equal, don't say bronze, the cost of a bronze, because that's what we want to know. And let's let S equal the cost of a silver token. And then gold is the cost of a gold token. So 3 unknowns, we need 3 equations. Look for total amounts. Tennessee uses 3 different colored tokens for their game machines. Okay, for $20, you can purchase any of the following: 14 times the money for gold plus 20 times the monetary value of silver plus 24b, and what's the total? 20. Yep, so all of these are going to be equaling 20. 20 gold plus 15 silver plus 19 bronze equals 20, and 30 gold plus 5 silver plus 13 bronze equals 20. So I've been consistent, gold, silver, bronze, so now I can put it in the calculator. Alright, and it says X, but G is in my X spot, and it says 1/2. Well, we're talking about monetary value, so this is one where I would want to change it to decimal, so that's 50 cents for gold. Alright, let's go down. The next one would be silver. 7/20. What is that? 7/20 is 0.35 for silver. And let's go back. Just go back to it. Go all the way down to solve. There we go. And then go down. 1/4. I know that's 0.25 for bronze. Alright, next one. Last Tuesday, Regal Cinemas sold a total of 8,500 movie tickets. Proceeds totaled $64,600. Tickets can be bought in one of three ways. A matinee admission costs $5. Student admission is $6 all day, and regular admissions are $8.50. Here's the question. How many of each type of ticket was sold if twice as many student tickets were sold as matinee tickets? Okay, you may want to pause the video and see if you can remember the tips I gave you. Alright, so we start here at the question, how many of each type of ticket? So X equals, what are the types of tickets? Well, there's a matinee, so we may want to call them M. Let's call it M for matinee. Let M equal the number of matinee tickets. And then we've got student tickets, so that S is equal to the number of student tickets. And then we have regular admission, so that's number of regular admission tickets. Alright, so we have three unknowns. We need three equations, and you're looking for totals. Do you see a total? I do. 8,500 movie tickets, and they are made up of these three. So number of matinee plus number of students plus number of regular is equal to 8,500 tickets. So we have a total ticket equation. And then we have a total money equation. And we're told that matinee costs 5, so that would be 5M. And student is 6, so that'd be 6S, and regular is 850, so that'd be 8.5R, and we have a total money amount. So this is money. This is $5. This is money. That's money. That's money. So everything's working out. All right, we need one more equation. All right, so that is coming here if twice as many student tickets were sold as matinee tickets. So do you remember my little trick? We are comparing student tickets and matinee tickets, and twice as many student tickets were sold. So there were many more student tickets than matinee tickets sold, right? Okay, so you want to put them on the opposite sides of the equal sign. So I'll put an M here and an S here, and you have to know what twice means. Twice means 2 times. Where are we going to put the 2? Are we going to put it with student tickets or matinee tickets? You ask yourself, who needs the help? Okay, so we know student tickets are the one that's more. So who needs to help to make this equal? The 2 actually needs to go with the matinee tickets. And you can test it out. If you sold 10 matinee tickets, you would sell 20 student tickets. Alright, so the next thing we need to do is make sure this goes in standard form. And we've chosen the order to be MSR. So 2M is already on the left. There is no R, so that'd be 0R. We have to move this S over here, and so then it equals 0. So there's your third equation. Let's see what the answer is. Alright, get it all typed in, and I typed it in fast. You got pause on your computer. Alright, so X, which is our M, because it's first, so that's 3,400 matinee tickets. Get the down arrow. Y, but that's S, since that was second. And that's coming out to be negative, so that tells me I made a mistake somewhere. Alright, rather than edit this out, you have to use your critical thinking skills. So I'm just demonstrating that. I made a mistake and I had to go find it. I know that it can't have negative answers. You wouldn't believe the people that write down that. But anyway, I see my mistake. It's right here. See this? So I have to stay in the order that I started with. So M and then S is next. So that needed to be 2M minus 1S plus 0R equals 0. So now I can go fix my error. So go here and make that 0 become a -1 and make that -1 become a 0. And now we'll solve it. And there we go. So 900 matinee. You got to look for errors. You are going to make mistakes because nobody's perfect. And so part of finding your error and reasoning through that is good critical thinking skills. So work on that. And you've got to be doing a lot of homework problems so you can correct those errors when you make them. And that will reduce your test anxiety. All right. Okay. Number 4. Kitchen corner produces refrigerators, dishwashers, and ovens at 3 different factories, and the table gives the number of each product produced at each factory per day. Kitchen corner receives an order for 110 refrigerators, 150 dishwashers, and 114 ovens. So much going on. 3 different factories, 3 different appliances, and then question is, how many days should each plant be scheduled to fill this order? Okay, so this table, factory A, this means that they can make 8 refrigerators, 16 dishwashers, 10 ovens in factory A. Factory B, they can make 10 refrigerators, 12 dishwashers, 18 ovens. Alright, so this is an incredibly difficult problem at first, okay? But you want to start with my little tip, and that is go to the question. Okay, so the question is, how many days should each plant? So that means that I'm going to let A equal not number of refrigerators, dishwashers, and ovens, but how many days at each plant. So A is going to represent the number of days in factory A. All comes from the question. B is going to be the number of days in factory B. So I don't know how to do a problem when I read it instantaneously. That's not how that works. But I do know, because I've been teaching for a long time, but even if I were a student, I know what I need to do is look at the question, and that I'm not going to panic. That's going to help me. So I now know that A, B, and C represent days in each factory. Okay, and then I'm going to read the question again. Alright, what does the table give me? It gives me the number of each product produced at each factory per day. Okay, and now I'm looking for total amounts. Do I have a total amount? Well, Kitchen Corner receives an order for 110 refrigerators, 150 dishwashers, and 114 ovens. So those are total amounts. So what that tells me is I need a refrigerator equation. So then that opens up this table. See how this line is all about refrigerators? So 8 refrigerators in factory A, that's going to take 8A days. And then 10 refrigerators in factory B is going to take a certain number of days. And then 14C, that's a certain number of days. And then they want 110. Refrigerator equation. So 8 times A plus 10 times B, that's refrigerator equals refrigerator. So once I figure that out, I know I'm just going to read across this way. So we have 16A plus 12B plus 10C equals a total 150 dishwasher. So we have a dishwasher equation. And then 10A plus 18B plus 6C is 114. And so that is your oven equation. So if we solve this system, we'll figure out how many days it's going to take to do this. Okay, so let's figure this out. So 8, 10, 14, 110. And we get X, which was really our A, is 6. 6 what? Well, we labeled it number of days. So 6 days in factory A. And then 2 days in factory B. And 3 days in factory C. Alright, let's look at this one. Number 5 says find a polynomial of the form f of x equals a, x squared plus b, x plus c, which passes through the point 1, negative 6, negative 1, 2, and negative 2, negative 3. This is a completely different problem. These are order pairs, but we want to find a, b, and c. Okay, so what we're going to do is, if you remember how to write a polynomial function, remember if you're given a point, you can put this in for y and that in for x and solve for your unknown. But unfortunately, we have 3 unknowns. Well, it's not that unfortunate. If you have 3 unknowns, you have 3 equal order pairs, you can write 3 equations. So let's use the 1, negative 6 one. 1, negative 6 means that this is x and that's y. So f of x is y. So y equals a, and then 1 is going to go in for x here, and then b, and then 1 is going to go in for x there, and then c. Alright, the second order pair is negative 1, 2. So that would be y. I forgot to put my negative, so just go back. We're trying to find a, b, and c, so I'm going to put negative 6 in for y. Alright. Then the second equation, we got y, so that would be 2 equals a times negative 1 squared plus b times negative 1 plus c. And then my third order pair, negative 2, negative 3, would be negative 3 equals a times negative 2 squared plus b times negative 2 plus c. Okay, now let's clean this up a little bit. So we can do a little arithmetic. 1 squared is 1. Alright, so this is 1a plus 1b plus 1c equals negative 6. Right here, negative 1 squared is positive 1, so that's 1a minus 1b plus 1c equals 2. This one, negative 2 squared, that's positive 4, so that's 4a minus 2b plus c equals negative 3. I just wanted to write them in standard form. So that's pretty clever. Use the order pairs, plug them in for x and y, and let's solve for a, b, and c. Alright, put it all in and solve. And x is -3. Well, that's our a, right? So -3, or y equals -3x squared plus, let's see what b is, a -4, -4x plus z. That's our c. So there is our function. If you want to use f of x, you can. Alright, last one. Mabry invests $50,000 in money market accounts at 3 different banks. Bank A pays 3% interest per year. Bank B pays 2.6%. Bank C pays 4%. She decides to invest twice as much money in Bank A as in Bank C. And after 1 year, Clarice has, oh, I forgot to change the name. So this is Mabry still. Mabry has earned $1,533.28 in interest. How much did she invest in each bank? Okay, so this one, you're going to need a formula. You should have known it from middle school. We're not compounding. It's not compound interest. What this is called is simple interest. Okay, so simple interest, the interest from an amount is equal to the principal, the money you invest, times the rate, times the time in years. Okay, so again, we're going to go to the question. How much did she invest at each bank? Bank A and B, there are 3 banks, A, B, and C. So we're going to let A represent the money in Bank A. B represent the money in Bank B. And C represents the money in Bank C. So we need 3 equations. So do we have a total money amount? $50,000. So she put $50,000 in all 3 different banks. So that's A plus B plus C equals 50,000. Okay. Now the second equation that I'm going to look at is another total. Do we have another total? Well, this is a total amount. This is the total interest amount. So this is going to be over here, 1533.28. Okay, so how do you calculate interest? Well, interest is principal times the rate times the time, and the time says after 1 year, so this is 1. So the interest is principal times the rate. Okay, so the interest rates are given. Bank A is 3% interest. So if we convert that to a decimal, that's 0.03. So A is the principal, that's the money. So 0.03A times 1 is your interest from A. And then B, 2.6%, that's 0.026 times B. And then C, the interest is 4%, 0.04C. And I'll rewrite this total. So this is your interest total. This is your money total, or principal total. So we need one more equation. Do you have a comparison? It says she decides to invest twice as much in Bank A as in Bank C. So this is our 3rd time we've done something like this. She invested twice as much in A and C. So who'd she put more money into? Bank A. Okay, so what we're going to do is we're going to put A on one side, C on one side. A, she put more money in A. Who needs the help? C. Okay, so now I need to put it in standard form. I'll try to do it right this time. 1A plus 0B minus 2C equals 0. All I have to do is move that 2C term over. So those are my 3. Let's see what we come out with here. So we have 1,150,000 and 0.03, 0.026, 0.04, 1533.28, and 1, 0, -2, and 0. And you get some nasty answers. A is our X, so that's the money in bank A. Round to the hundredths place. And 18189.09 in B. Don't forget your units. And $10,603.64 in C. And does that look like twice that? It does. Okay, so those are word problems. You'll have some in WebSign to practice, and you can redo these over in a couple of days and see if you can remember how to do them.